Well, hi there, everybody. This is Justin Dyke from cartoonsmart.com, and I've been playing around with the tvOS. I think I've been saying it backwards, osTV, right? So yeah, let's get off on the right track and call it the tvOS, like iOS. I just got to remember the OS is at the end. And what you're seeing here is kind of a hypothetical intro screen to a SpriteKit app. Oddly enough, none of the content on here has anything to do with the game, but I was just creating some graphics for a new lesson that we're going to start selling at the site. So I figured, oh, these look nice. Let's go ahead and put them. They do look TV-ish, you know. But this is a SpriteKit scene, and what I'm kind of doing here is simulating the look of some of the stuff that we saw with the Apple TV in the demonstration. So if I touch down over here, you can see I can kind of wiggle around the in focus element, and if I drift over here, obviously I can do the same thing with that one, and then the previous one slides into the background, and same thing for this one over here. And you'll also know that I'm moving around a SK sprite node so that the element that is in focus is actually getting lit up a little bit more as well. And then I'm actually not selecting any of these. Okay, I'm just bringing them into to focus, and that's just a fancy term for just basically scaling them up. And but if I did want to touch down on them, we've got a couple ways you could do that. I could just kind of tap into the remote here. I could also press this button, and of course you're not seeing anything because there's really nothing to see. But if I had the output window open, where is that? There it is. You can see I've touched a few times already. And then we're also going to talk about how to detect if you're just kind of pressing up over here, left, right, or down, and then also if the user swipes in those same directions as well. So there's quite a bit here, but nice thing is if you're already a SpriteKit developer, this is not going to seem like the craziest thing in the world to adopt. From what I've seen, a lot of the code that we already use is going to be just fine. And one thing I should note too is the kind of tricky thing about this is that when you touch down inside of here, so I have to hold down Option, right? When I hold down Option, it basically makes the position, let's say the CG point of where I'm touching, the middle of the screen. Okay, so like right over here. So even if I'm over here in the top left of the remote and I hold down Option, the position is still considered to be right there in the middle of the screen. Okay, so every movement after that is then relative to that central position. So you'll notice that, let's say I'm over here in the far right side of the TV remote. I press down, okay, and I've now selected that middle object, okay, because my touch event is basically, location is in the middle, and I may or may not be able to get over enough to be able to select that far off element, right, her over here. And obviously I've got plenty of room though where I can move over here to this, but I think that's just going to be something that users of the TV are going to have to get used to, that, if you want to get to something over here, well, don't start touching on the far right side of the remote. But, I've read some things online that were kind of saying like, well, you can't detect your position and all this stuff like that. Well, that's not necessarily true. You just have to factor in that all of your positions are going to be based off touching in the center of the screen. So it just takes a little bit of not even math really. You're just, I don't know. We'll explain it later. But that's kind of the intro to this and what you can expect ahead in the lesson. So I don't like to kind of open up a lesson in the middle of what I've already done. And with that in mind, let's go ahead and create a brand new project. So what we'll do is we'll go over here to File, New Project, and we're going to specify that this is going to be a tvOS application. We're going to pick on SpriteKit here, click on Next, and we'll just, a lesson on tvOS. And we're going to make sure that the language is Swift and the game technology is SpriteKit. Just click on Next and put that wherever happy place you want it to live on your computer. And then from here, what we're going to do is bring in some assets to use, and I've got those on my end. You can, of course, bring in anything that you want. So what I'm going to do is just drag these in from the desktop. And here they are, just just 5 of them. Look at that. And I just told somebody recently, I was like, that's it. We're never going to have to worry about 1x images again. Well, sure enough, there they are, because the Apple TV does not want 2x images. It wants 1x images. With that in mind, you can just drop these in. Of course, if you did happen to name them with @1x, like I did, it's unnecessary, but you could. They're going to fall into these 1x slots. Accordingly, if you had 2x in there, they're going to nicely put themselves in the 2x slot. What we need to do is set up these images for the Apple TV. Oddly enough, even though we specified that this was going to be an Apple TV app, our images want to come in here into these universal slots. So all I'm doing is right-clicking and then just moving these over here. And you know what? I think these are actually an older image set that I'm playing around with now. Oops. So I'll have to fix that in just a moment. But every time I right-click, I'm just creating a new slot for the Apple TV, taking this one out of there, and then right-clicking again to get rid of universal. And then finally, one more of these, Apple TV, drag this guy over to here, and universal. There we go. Okay, so these are pretty much set up. I'm going to have to pause, and what I have to do is I have to crop these. And then we'll come back and we'll do some coding. And actually, I spoke too soon. We're not going to have a code right yet. We're going to put those elements into our scene. Our gamescene.sks file defaults, at least right now, to 1024 by 768. That is the size of an iPad. So let's change this to 1920 by 1080. There we go. More like the size of a TV. And then from here, what we're going to do is just grab a bunch of color sprites. So this first one over here is going to be our background, and let's get that right over there. This is actually, oddly enough, not exactly the right size, but that's okay. We'll just adjust this a little bit. And if we have any hanging over the edge, that's a-okay. Not a big deal. We don't have to be too perfect there. I'm going to give this a name of background because with the code that I've written for this, what we're going to do is kind of cycle through all of the color sprites or SK sprite nodes in the scene and do something accordingly. But the background I do not care about, and even though I love my logo for Cartoon Smart, in terms of this project, I don't care about either. So I'm going to call this logo, and you'll see once we begin writing our code that the background and the logo are the two names that we are just going to exclude from doing the fun stuff in here. So now let's come over here to color sprite. We're going to call this, I think I've got cover for the cover page, or just the whatever. Kind of the pseudo poster for the the project. And let's just get all these on here first. And I think I've got one in here called iPad. And one of the things that I think everyone is going to find when they are making something for the Apple TV, and certainly when they actually put it on their Apple TV, is that the size that you would have something for an iPad is going to really be different than what you would want to do for a TV. And I kind of laid some of this stuff out in Photoshop first, and I was like, that's perfect, that's great. And I realized, you know what? I think these are all way too big, and you have to consider too that there's just a color safe, or just a TV safe area, which, imagine this red zone right here is actually the safe area. So you can see that with all of my images at those current sizes, they're going to be a bit too big, and they're going to feel a little too squashed. So what I'm going to do is I'm just going to select every one of these, and I'm going to take the scaling down from 1 to 0.7 on the on both axes here. There we go. And with the code as well, what we're going to do is use those numbers to basically have a unfocused scale and a focused scale. So the focused one is going to go up, not to 1, because I think that's still a little bit big. If we programmably, if we set this back to 1, it's not going to be 100% of what it is right now. It's actually going to go back to that original size of this right here, which again I think it feels a bit big. So keep that in mind. That don't feel too committed to the sizes that you bring in. They don't really matter if we're going to change it with the code. And then per Apple's guidelines, what they want you to do is use the San Francisco font for your app. And there we go. Either the believe it was the display or outline one. Or maybe it was the text. No, I think it was the display one. All right, so let's make this a little bit bigger. Obviously, that would be pretty small to read. And I think that is 72 is getting into the very legible zone. So we'll just say pick a lesson below. All right, ... And, of course, we'd want to center this right about there. Isn't 960 half of 1920 our width? Okay, last thing we have to do is, no, actually we got a couple of more things inside the scene. We're going to call this button 1, button 2, because essentially that's what these are. They're going to be buttons for us to work with. And it's just easier for me to remember them as button 1, button 2, and button 3. And then let's bring in our lights. So I'm going to take one light, put it right down here. We're going to call this guy light 1. And I'm going to set the Z depth well above everything else. Put that at like 500. And then I'm going to take another light and just kind of put it up here. Call that other light, if I could spell light correctly. And this one we're just going to kind of leave hovering. This one is going to be the one that we're going to move around. And if you have your lights set up properly, you're going to actually see those changes in the scene itself. So guess what? We need to do a little bit of work. You can see that the lighting mask is set to 1. So go over here on button 2, and let's set the lighting mask to 1. There we go. Do the same thing. Here we can do it. We can select both of them, and then you'll notice that when I do move this around, it makes a huge difference. And even though I'm not moving this one too would make a difference if we were moving things around. And I don't think that this is the scene for it, but you keep in mind that you can also set your shadow cast, and you'll notice that well, we've got 2 lights in here, so it looks a little funny, but there you go. That kind of gives you a good idea of what shadowing does in SpriteKit. Okay, so let's definitely turn that off. Set that back down to 0. And what I also want to do here is be able to set these buttons back to their original location. So there's a couple ways we could do this. We could purely do it with code. Another way we could do this is to put in here a button placeholder 1. Okay, so we're just going to give this a name. This is an empty sprite, and there's not much to it other than its, well, for our purposes, its name, okay, because we're just going to use it for positioning things. And you might be wondering, well, why are you putting them up at the top of the screen? Is it because you don't want to see them? Well, no, they're empty, they're invisible. So then you might be wondering, well, how come you're not putting them where these images are right now in their exact same location? Well, it's because when we initially load this up, or run this with our code, we can just say, hey, take all these placeholders and put them where each one of these are, okay? And then from that point on, we're never going to move them again, so these are going to be at the exact same starting locations. And then after that, we can say, okay, well, button 1, you were unfocused, so you're going to go back to being at your placeholder, which was wherever it started at. So it's up to you. You can drag them down there. But I think we are now ready to go. Let's write a little bit of code and go over here to your gamescene.swift file. One of the things we're going to do is clean this the heck out. So get rid of all that goofy stuff right there. And we are going to make use of our touches began statement, so you can leave that in there, and you can also leave this inside of there as well. Okay, so let's call a function after we have gotten our touch location, and this function will be named, how about just check touch, and what we'll do is we'll just pass in that location value. And this kind of simplifies things because we can also call this same function anytime we do touches moved. And you know what, while we're at it, let's just go ahead and do that right now actually. So we'll just change this to touches moved. And all right, now let's go about writing that function. So I'm not typing at the bottom of the screen. Here we go. All right, so here's the function. We're going to call it check touch. And what we want to do is pass into this a CG point variable, which throughout this function now will be referred to as location, just like the name over here too. So we're just basically taking our location, putting it into here, travels down, and it comes out back over there as the same value. But again, we're just doing this so we don't have to write the same code in two different places. And from here, we are going to write self enumerate child nodes with name, and let's type it like this. Just there aren't going to be any references in this file, but if you did have some SK references, the double slashes in front of them are going to be able to find any children inside of those as well. But I mean, you know, we could get away with just putting that right there. And what this is going to do is going to iterate through all the children in the scene, which are really not that many. We just have our background, our logo, and our buttons. We got some labels too. So really everybody gets looked at, but we're going to kind of isolate who we care about within here. So basically, this is going to run for every single node, okay? And when it finds a node, we can now refer to that particular one as just node, right? If you ever need to stop this, what you would do is you'd write stop memory equals true, but we don't need to do that. I think I've slowed things down. I'm downloading documentation right now. All right, so here we go. Let's write if and then dot node name. If it does not equal background, okay, then we're going to do something. But I also want to check to make sure that if the node is not that logo as well, because I don't care about either of those. All right. So as long as it's not either of these two guys, we're going to kind of continue going through here, right? And from that point, what we'll do is say if, and we'll say let sprite sprite node equals node as sprite node. And what this is going to do, let me just go ahead and close this off. It's right, and that's just going to get completely ignored because it's not going to basically pass as an sprite over here. All those ones that we added to the scene as color sprites, of course, are now going to get looked at. But at this point, we're going to refer to them as sprite. So we no longer have to worry about calling this node. It's just going to be sprite. And then what we can do is write if cg rect contains point, and we're going to check to see if the rectangular area of the sprite, and that's just going to be its frame, okay, intersects with our location. And that's that CG point right there, location. If so, that means that where we touched down is within one of our buttons. So at which point what we're going to do is bump the scale up. And this is really easy. We just write in here sprite.xScale is going to equal, and I'm going to make this equal to a variable. I'll just go ahead and type this out, and then we'll come over here to the top of the file. Because we are enumerating through our children's here, they kind of insist on us putting self in front of this, I guess, just to be a little bit more clear, the variable that we're referring to. And let's go ahead and write that little guy right up here to the top. And I believe that this is going to be a CG float type variable. So we're going to put in here let focus scale. That's going to be CG float. And what did we say? That was going to be 0. Oh no, you know what? This is the focused one when it is in focus. So we're going to bump that up a little bit. We'll make that be 0.85. And then while we're up here, let's just go and paste in here the unfocused. I guess I'll change that to plural, and this will be our back down to 7. Okay, so that's what we started at, and then let's continue writing. So we'll go back down here. What we want to do is then, of course, adjust the Y scale as well. So this Y scale is now going to equal that dot focus scale as well, and then what we're going to do is take our sprite, put it at a Z position of 100, and then write self dot focused node is going to equal sprite. All right, what is our focus node? Well, now that we've kind of landed on somebody that's, you know, is going to be in focus, let's keep track of them throughout other function so that we can refer to, or so we can get back and know who is the focus node. And all we have to do is come back over here to the top of the file. We're going to write var. This will be focused node. I guess I could have called that sprite too. That's all right though. And there we go. That little red warning should go away in a second. And if you wanted, you could, at this point, write print, let's say focus node dot name. Now, keep in mind, actually, we are calling this when we move around. Okay, so we could test this out. Let's give it a shot. Wait for that to should disappear, right? Maybe not. Maybe we have to pull the value out of it. All right, what's the problem here? Oh, you know what? It probably wants this. And maybe it doesn't want that exclamation point. We'll just see. Now, of course, what's going to happen here is when we touch down and move around, all of them are going to become in focus, and we're not going to see them go out of focus. And what did I do wrong? Let's see. I noticed this once before. I just kind of forgot about it. All of our objects right now are at a z position of 0, and it seems that in this latest build, it really doesn't matter. Even though that these are visually above the other elements that are at 0, it's best to now just explicitly say, all right, well, let's put you, and I've got the background selected, at -1, and that way there's no issues with these being hidden behind the background, which is what was happening. All right, so back on track. Let's test this out. All right, so now get the remote up, and if you don't have the remote up, go over here. I'd say learn that hotkey, Shift Command R. And I've also found that when using the remote, it's best to kind of select it first and then begin tinkering. Okay, so you can see that I'm moving around and I'm making all of them bump up, of course. There's no else to our if statement here, so none of them are sinking back down. They're all just staying selected. But we are seeing that the name is coming out of them, so that's, of course, a good sign. And I guess let's just go ahead and get rid of that for now. It'll be pretty clear which one is our focus node because, well, that's the whole point of this, right? Making it clear. All right, so we've got a little bit more work to do inside of this, but let's not worry about it for right now. Instead, let's go out of there and let's put an else statement right here. So we're just going to say else. So this is going to be what happens if we are not intersecting with that particular frame. And of course, as long as we don't have overlapping objects, which would just be kind of poor taste design wise, we'll be okay here. There's no chance of us having kind of two on top of each other. So what we're going to do now is say if, and then sprite does not equal self dot focus node. And you might be wondering, why are we doing that? What's that even mean? Well, we could, let me get the simulator back open over here. Suppose we're kind of going back and forth among these ones. All right, now at some point you're going to have to decide, hey, I want to choose one of those. Okay, so then what the user is probably going to do is, all right, pick up their thumb, right, and then, well, they're either going to tap down or they're going to travel over this way. But the point is that they might move over here and they might move off of it, but they still want it to be selected. Okay, they've still got this kind of in hand, and then they're about to start using it. So if they drift off, we still want to leave that one in focus and not do anything with it. So as long as it's not the one that we've selected, basically we're going to shrink it back down. I guess I'll put a little note here. I'll say as long as it's not note selected, then shrink the button back down. Okay, now from here what we're going to do is take the Z position. Let's put that at well, we'll put it at 1. How about that? And so that way whoever is selected is always going to be visibly on top. And then we're going to say, we're going to run some actions here. We're going to write let scale action, and this is going to be sk action. This is going to equal sk action dot scale to, and that'll fill itself in for you. We're going to put in here self dot unfocused scale, so it's going to go back down to that value, and then you get to decide, you know, how long that's going to take. 0.5. This simulator is a little sluggish, so might as well just make it quick, and it'll be a little quicker probably on the actual device, but we can always adjust that down the road. And we're going to write dot ease out, and then and sorry, I should explain that the timing mode is so it's going to ease out. Your other options here are ease in, ease out, ease in, or just linear. Linear, I think, does not look nearly as smooth as easing it out. And then we're going to say sprite dot run action, so that this is going to be the object that is running the action, or basically getting scaled back down. So then you just want to put in there scale action. And now at this point, what are we going to do here? We need to, well, we could test this. Let's do it. Things will look a little brighter than before. They'll look better. Okay, so I'm back over here. I'm going to hold down the option key. And, all right, so I gravitated off that one. Let me go back over here. There we go. Back over this way. And I did not make it all the way over to there. There we go. All right, so obviously these are not lighting up yet, and they're not changing their position, so they're gonna, you know, stay where they're at. They're just scaling up and down. But if we want to add that little wiggle effect in there, that's where our placeholder comes in, because if we do, you know, when they are in focus and we wiggle them, they're gonna move around a little bit, and it's possible that they could get closer and closer to one another. So let's go back over here to the top of the file. We've already got our placeholders in there, and since this is kind of no-brainer code, I'm just going to go ahead and type it or copy it in here. So we're just saying self.child node with name button 1. Oh, actually, I'm sorry. This was not the code I thought I was going to paste in, but we might as well do it anyway. I'm just setting the each one of these buttons to their unfocused scale value initially. And here's the code that I meant to copy in, but this is just as good because, as you can see, it's all pretty much the same. It'd be boring to watch me type that out. All right, so what we're going to do is write self.child node with name button 1 placeholder dot position is going to equal self.child node with name button 1, and let's make sure you can kind of read this all as one line. Button 1 dot position. So basically, we're taking our empty placeholders, and as soon as the view loads up, we're making each one of them equal to the button 1, button 2, button 3 position, and that way, when we release or we make these unfocused, we can send each one of them back to their position again. So to do this, and we'll even make this a little bit fancier with an SK action, we're gonna write a variable here. It's gonna be called placeholder, and then CG point is gonna equal CG point 0, and then depending on who we select, we're gonna change the value of that placeholder. So we're going to write sprite.name is going to equal button 1. And of course, there's always a million ways to do everything with code. This is maybe not the most fantastic way of doing it, but it's for just having 3 buttons, it's perfectly fine. Other ways you could think about it would be maybe writing a dictionary to store all the initial values, things like that. All right, so if the sprite.name was button 1, in this case, we're going to say placeholder is going to equal self.child node with name and button 1 placeholder dot position. And actually, even just looking at this right now, I can think of a way we could optimize this. Oh, and you know what? I believe in over here, I called each one of these. I had that at the end of it. You know what? Let's do this. I'm sorry. I'm going to change that. Button 3. Button 2. Button 1. Save that out. And I'm kind of laughing at myself because I there's so clearly an easier way of doing this instead of testing which one the sprite name was, but we'll just proceed. Maybe someone else has thought of it too. All right, so at this point, what I'm going to do is I'm just going to say if the placeholder does not equal cg.0, then we're going to go ahead and perform our move action. So as long as this got changed at some point, this placeholder value got changed from being cg.0, which is just 0, 0, then we're going to do our move action. So we're going to say let's move action sk action. This is going to equal sk action dot move to, and this is an exact location, not move by, which would offset it. So we put in there our placeholder, and then yet again you get to choose a duration. I'd match it up to whatever you had before, and then move action dot timing mode is going to equal and yet again I would probably keep the timing modes the same, ease it on out, sprite dot run action move action. And I think we've dealt with our placeholders at this point. So let's check it out. Ooh, you know what? Well, what did I do here? Obviously, that's probably from changing the name. Did I not actually? Maybe I didn't get it. All right, what's that say? Button 1 placeholder? Did I give it the wrong name? Well, I was going to bring this up earlier that and you know what? I might have to clean it out. No, that's the right name. This is something that you would probably want to put inside of an if statement just to make sure that you're not forcing a value out of something that does not exist, put it that way. Let me run that again and just see if it still crashes. What might have happened is it didn't register the change in the scene file when it built it, or the simulator crashed. I mean, it cached the. Well, let's see, there it's running fine. It cached the previous names inside of there. All right, so back over here in our remotes, and you can see that. Well, actually, obviously, in the effect where we're going to move these around a little bit, but in theory, they are moving back to their placeholder. So let's go ahead and wiggle them around when we touch down on them. And to do that, what we're going to do is put a little variable up here at the top, which is going to be var last location. So we're going to kind of keep an eye on our last location that we touched or that we moved around from. And I'll make this CG point make, and my math is not great on this, and in my notes I'm actually looking at the iPad settings, which I think, let's see, you know what, let me just test this real fast. This is the TV size right here, and that's the same size as our screen. But I do want to just double check that when I touch down, let me print out the location, and this actually would have been a nice thing to kind of lead off with so you guys could see what that location was when you initially touch down on the remote. It's always the same location. I think I've made that clear, but it'd be nice to actually see it. So, okay, I'm going to come over here. I'm going to hit the Option key. Okay, all right, that's what I thought it would be, 960 by 540. Previously, when I had the width of the scene set to that of the iPad, I was getting different numbers over there. And so you can see that every time and I'm just hitting the Option key over and over again, every time I do this, I'm getting the same starting values, even though I'm obviously changing, positions drastically within here. And if you wanted, you could then also take, that print statement, put it into your touches moved, and then see what happens when you kind of move around. So you can see the values make sense. So I'm going to hit here. All right, start at 3, 2, 1, press down and move, and you can see that 540. I'm going straight across and down. So they do make sense, but they all just start from that same central spot. All right, so with that in mind, what we're going to do is keep track of the last location. All right, now initially that's going to be half the screen on both the Y and the X. So we've set that up, and then I'm also going to create a variable and this one is going to change, but this is not going to change. So I'm going to put in here let, and this is going to be our wiggle amount, and this will adjust kind of how wiggly or how much you can wiggle those images when you've got them selected. And put a little note here, less is more. All right, more wiggle, I should say. So the lower the value, the more wiggle. More wiggly. All right, now let's come on back down to our when we get our node into focus. Okay, so, and actually even a little bit above that, what we're going to want to do is start to set this up outside of enumerating through the children. We're going to say let x difference, so just to shorten that, x diff. And this is going to be a CG float type variable. This is going to equal, I'm going to go ahead and put this in parentheses here, last location dot x minus location dot x divided by the wiggle amount. Okay, and you know, so if that was 1, there's really no effect on this, no division, and it's you can kind of send your image all sorts of different places. Let's think about this. So, you know, we're basically just comparing the last location to the current one and dividing that value. So, you know, depending on which way you go on the x-axis, that's either going to be a positive or a negative value. And the whole thing is kind of shrunk down a little bit because we're doing this division, and it just makes it so that what we can do is add this to the position of whatever we've got selected. After you figure out these numbers, what you're going to want to do is take your last location, make it equal to the location. Okay, so then it gets saved for the next time. And of course, if you hadn't done that, then you'd get some really high numbers each time you moved around. But because we're setting our last location to the most recent one, it's just these kind of fractional values. So it's just telling us that we haven't used our x diff, y diff, and that is about to change because we're going to come down here and let's see where we're doing that. Okay, right over here, I'm going to say sprite dot position is going to equal CG point make, and that's going to be sprite dot position minus the x diff, and then of course we're going to do the same thing for the y. So let's just be lazy, paste that on in there. I can definitely tell, look, downloading that documentation has slowed down Xcode for me. And once we've done that, I think we've almost got all of our code written. Let's go and just while we're still in here, write in here if sprite.hasActions equals true, then what we're going to do is write sprite.remove all actions, and that way if you're kind of moving your finger back and forth really fast and you've still got a node that was leaving focus and it's scaling back down or moving back down to its location, all that's going to stop, and then suddenly this takes over. It's going to go to the right scale. It's going to we're going to start messing around with the position a little bit and all that other good stuff. So that's why that's in there, and we are really now at a great almost a great stopping point with 17 minutes on the clock. Of course, this video is way longer than that. This is since the last time I stopped recording. That's what that is. All right, so here we go. I'm going to press down, and you can see already kind of moving that around. And I'm going to slide over to this one. That guy goes down, so I can move up and down with this guy. And go back over this way. That one goes down. Let's go over here. One thing that we haven't done, though, is moved our lights at all, which kind of looks terrible because everything looks really dark, doesn't it? And let me see, where's my update statement? Here it is. Let's move them lights. What we're going to do is write if focused node does not equal nil, so that means that we've at least focused in on somebody. Then what we're going to do is write self dot child node with name light 1 dot position is going to equal CG point make, and what we're going to do is take our focus node. So focus node, you know what we're testing to see to make sure that's not nil, so we can force a value out of that. It'll be dot position dot x minus 100. So wherever the focus node is at, this light is going to be minus 100 from it, so it's just not dead center, I guess. I'm not even really sure why I did that. Maybe I should make that just the focus node position. Well, you know what it was? I originally had 2 lights following them around. It was just kind of blowing everything out. And then for our next one, we don't even need these double parentheses in here. Clean that out. And then for the Y position, though, I do want to actually have the light subtracted a bit from the focus node's position, so the light's kind of hanging below it. Yeah, I think we got that. You know, I guess one thing we should do here is just and self.child node does not equal nil. Make sure that actually exists. Because that was why we crashed earlier with trying to force a value out of something that may or may not be there. Okay, so let's come back over here again. And obviously it looks like our light has moved. Okay, there we go. And that was actually a good example of how the, hopefully you saw that this kind of was over here a little bit and then went back to its other position. And you can see now I've kind of let go of everything, but I've still got this selected. So, you know, via my remote or, you know, my couch experience is that I've got this ready to go, and then, you know, I can hit over here, or maybe I could just tap to select it. And of course now I'm just moving around again. And let's see how she looks lit up. So things are maybe a little bit dark. I would probably move one of the lights back down some in the scene. Maybe take that over here or something. See how that looks. And you know, another thing you could consider is running an SK action on whoever you've got selected, which is really actually pretty easy. If we were going to do that, what I'd say is we need to then remove any actions on the unfocused node, because if we're going to run a repeating, let's say, up and down action on the one that we've selected, we then want to also kind of kill that effect. And let's see how quickly we could do this. Let's take our previous move action. We're going to change this to move by, and actually, you know what? Move by nothing on the X. On the Y axis though, let's bump this up by 20, make the duration be 0.5, get rid of that. If we're just bobbing this up and down, then I would actually say the timing mode is fine linear, but you don't even really have to specify it because that should be the default. And then we'd want to name this move up action. And then we'd say let move down action sk action equals sk action dot reversed actions. We'd reverse the move up action. Some actions are reversible. This is one of them. And then we're going to want to set up a sequence. So this is going to be sk action equals sk action dot sequence. And inside of here, do an opening and closing square bracket. And then we're just going to want to move up and then move back down again. And I think, do we have it? Where did it want me to insert that? That's a little weird. I'm not seeing the problem. You know what? We're live, people. Let's just do this the way I should have from the start. We'll just make that -20, and there we go. All right, so here we go. Little off-the-cuff coding. Let's see what happens. We should have just a nice little up and down effect when we select somebody. So now we've got that. And oh, you know what we forgot to do? We forgot to run it forever. So we're going to say let's run forever. SKAction equals SKAction dot repeat action forever, and that's going to be our sequence. So then this comes down here. That's what we're actually running now, and I think that was a little fast what we saw. So let's take the duration down. And of course, even though that is saying it's going to run forever, that is unless we were to stop it. So there we go. It's kind of just hovering there, and we still have the, we can still move it around a little bit. Let's go back over to here, this one, and of course that one to the right should have stopped. And there you go. Got a nice little bobbing effect there. So what we'll do is we'll come back in another video and we'll talk about some of the gesture recognizers to tap and select things, and also to swipe your way around the world. And of course, those are key components of any sort of SpriteKit game. And don't forget to, seeing this, don't forget to visit cartoonsmart.com. I guess that has been littered throughout the tutorial the entire time. So why am I even mentioning it? But we've got an awesome starter kit over there for creating children's books without even writing any code. You just put properties into a property list. It's incredibly simple, but you do get to work in Xcode 7 with Swift 2, so that's what's under the hood, and design your book with using all the nice fun features that now exist here in Xcode 7. And also too, we are going to be supporting that kit with the tvOS. So we'll make it just as easy to make an iOS children's book app as it will be to make a tvOS one. So check that out, and we are going to continue this lesson in another video.